Hi everyone, this is Chandan and you are watching the learning field. So in this video, we are going to discuss the companion matrix. Okay, so companion matrix basically a special kind of matrix which has some special characteristics, and in linear algebra, this companion matrix is a very क्या बोलूँ मैं जो weightage है in the field of linear algebra from the different point of view of different competitive exams of higher maths. Okay. So today in this video we are going to discuss what is companion matrix, how can we write the companion matrix, and if there is any special kinds of nature of this companion matrix, and so on, and the characteristics of the companion matrix, that is the eigenvalue, eigenvector, and trace determinant. These are the characteristics. So in this video we are going to discuss these types of things. So let's start, and before starting I am requesting you to all those who are new in my channel, please give a like to this video, share with your friends, and obviously subscribe the channel and share more and more with your friends, and don't those who are new, and if these contents of my channel are helpful for you, then obviously give subscribe and complete 10k subscriber as soon as possible. Okay, so now it comes to the definition. So consider the polynomial px equal to x to the power n plus a n minus 1 x to the power n minus 1 up plus ax plus a naught, where ai are the real coefficient. So this is a normal nth degree polynomial, and the companion matrix is basically associated with a polynomial. Okay, so now we represent, or we write this polynomial as a matrix form. Okay, so and that matrix is called the companion matrix. So now how can we write this? So see, so here a0, a1 are the coefficients of x0, x1, x to the power 0, x to the power 1, and so on, and the highest order of x is 1. Highest order of this polynomial is n, that is the degree of the polynomial is n. Now we first have to convert the coefficient of the highest order, or the highest degree of the coefficient of x, that is highest degree coefficient of the highest degree term in the polynomial should be 1. If not, then we have to convert the coefficient to 1. So companion matrix, we can write the polynomial matrix only when the coefficient of the highest degree term in the polynomial is 1. Now we write here the constant term, then the powers of powers of x, that is this is the power of x to the power 1 x, then power of x square, and so on, power of x to the power n minus 1 with a negative sign. Okay, in the last column of this matrix, this is a n by n matrix. That is, one thing is noticeable from here, that if the matrix, or if the polynomial is of order n, then the matrix is also a square matrix of order n. Okay, and the off diagonal entries are 1. Okay, so what is the representation of the matrix? The coefficient, that is from the lower power to higher power, starting from x to the power 0, the coefficient should be taken in the last column with a negative sign, and the off diagonal entries are 1. So this is a most general representation of companion matrix. Now in the questions paper, in any other cases, you can also see this matrix. So this is another representation of a companion matrix. Okay, some book says that this is general expression, some book says that this is the general expression, or most general expression of companion matrix. Now we can get from this matrix, or from this matrix only just for transpose or transposition करके, ठीक है, तो रो एंड कॉलम का पोजीशन, ठीक है, ट्रांसपोज करके ये मैट्रिक्स से ये पोजीशन आ सकता है, ठीक है. So see this the matrix, this is the coefficients are starting from the last row and last element, okay, with a negative sign, that is this is the coefficient of x0, coefficient of x, then so on, coefficient of x to the power n minus 1 with a negative signs. Okay, so this is last column starting from this corner, and this is last row starting from this corner. The like powers of, that is the higher powers of x, should be taken one by one. Okay, and this is the diagonal element of diagonal element. Okay, सब सुपर सब जो होता है, ठीक है, ठीक है, तो ये डायगोनल एलिमेंट से यहाँ पर ऊपर जो होगा वो, मतलब डायगोनल के ऊपर का डायगोनल का एलिमेंट जो होता है, आई थिंक दिस इज कॉल्ड super, and this is called sub diagonal. So super diagonal elements are 1, and in this case sub diagonal elements are 1. Now if we take a general very easy example, see, suppose px equal to x square minus 2x minus 1 or plus 1. So this is a 2-degree polynomial. Now therefore the order of the matrix, if we represent this matrix representation, then this is definitely a 2 by 2 matrix. Now how can we write this? So first the coefficient of x to the power 0 should be taken here with a negative sign. Since 1 is positive here, therefore we write here the negative sign. Then coefficient of x with a negative sign. Coefficient of x is -2. So if we write here with a negative sign, then this should be 2. And of diagonal entries is 1, the other entries is 0. So this is the expression, or this matrix is called a companion matrix associated with this polynomial, this one. Now comes to some characteristics, the most important things regarding the companion matrix. Okay, so the first one is the characteristic polynomial and the minimal polynomial are same, and this is equal to same as the given polynomial. So here this is the most important thing regarding the companion matrix. See, when we should use this concept, so if we in some questions, if we see these types of matrix occur in the questions or occur in the questions paper, then we definitely use the concepts of or the characteristics of companion matrix, so that we can calculate or we can find the answer regarding this matrix very easily. Okay, now number 2 is the determinant. Determinant of A is written as -1 to the power a into a0. N is the order of the matrix or degree of the polynomial, and trace equal to -an-1, that is the coefficient of x to the power n-1 with a negative sign. But I said that these two things don't remember. You don't remember these two things, but instead of remembering these two things or these two formulas or these two concepts, you can definitely find the determinant and trace of that matrix. How can we write the matrix? See, trace means what? Date means what? Date means product of eigenvalues, and trace means what? Sum of eigenvalues. Okay, now if we take this example, then definitely from this we can say the product of this eigenvalue equal to -1 to the power 2 into a naught means here 1. So 1, that is 1 is the determinant of the matrix, and we can also see by checking this is a very simple 2 by 2 matrix. And if the matrix is of higher order, then we can definitely, these two formulas basically very useful. But how can we find this determinant and trace without remembering these two formula? I am just saying that. So trace of A equal to minus of what? Minus of a n minus 1, that is a minus of -2. Okay, minus of -2 which is equal to 2. And if we see the trace is also the sum of the diagonal elements, you can say also from here 2. Now this is a very easy and 2 by 2 matrix, that's why you can calculate and you can verify. But if the matrix is of higher order, in that case, see, what is the date? Date means product of eigenvalues, and sum means trace means sum of eigenvalues. Now we read in the very lower classes, in the classes of roots, I think in BSc, such that if ax square plus bx plus c, this is a polynomial or is an equation, then what is the root? Sum of the roots equal to minus of coefficient of x by coefficient of x square, and product of root is equal to what? Coefficient of x to the power 0 by coefficient of x square. This is with a negative sign, and this is with not negative sign. Now here the monic polynomial, if coefficient of x square is 1, then definitely this a term vanishes here. Okay, now the sum of the root means, where here equal to the sum of the root means minus of -2 by 1 coefficient of x by coefficient of x square with a negative sign, which is equal to 2. See, the sum of the eigenvalues, this is equal to the trace of a, it's equal to 2, is equal to 2 from this formula. This is very easy trick. Okay, and product of eigenvalues means, we all know that product of eigenvalues means c by a, that is here the product is 1 by 1, that is equal to 1. See, this is definitely done. Okay, so this trick I just observe this trick and I will share with you guys. Okay, now for higher order matrix, if we take another example with a higher order matrix. Okay, now this one more thing is that the companion matrix may or may not be diagonalizable. Okay, so what is the relation between diagonalizability okay, number 2, nilpotent matrix. If any relation between, check if any relation between nilpotent matrix and there is any relation with idempotent matrix, and so on. So this target matrix here. Okay, so see, diagonalizable matrix. First we comes to this nilpotent matrix. Suppose if we take px equal to x square, then what is the matrix representation of this? So coefficient of x to the power 0 is 0 and coefficient of x is 0. Therefore we write 0 and 0, coefficients of x to the power 0 and coefficient of x to the power 1, and then 1 here and 0 here. So this is definitely what type of matrix? This is definitely a triangular matrix. Okay, and this is a lower triangular matrix, and we know that triangular matrix means this is not a diagonal matrix, and because of what? Because of this is a non-zero nilpotent matrix. Okay, so this is a nilpotent matrix, that's why this is not diagonalizable. For one example, that is, now if I take the second one example, that is x square minus 2x plus 1. If we take this example, then definitely this is minus 1, this is 2, this is 1, this is 0. And see, the roots of the polynomials are what? 1 and minus 1. Okay, 1 and minus 1, I think. No, I think, yeah, 1 and minus 1. Or we can take another example just for x square minus 1. If we take x square minus 1, then the matrix is 1 0 0 0 1 0 1 0. So this is a matrix also. Okay, and this matrix, the eigenvalues of this matrix are plus minus 1. The eigenvalues are plus minus 1, that is we get different eigenvalues, and this is not a nilpotent matrix. Okay, this is not a nilpotent matrix. So the companion matrix may be nilpotent matrix or may not be nilpotent matrix. Diagonalizability, the companion matrix may be diagonalizable, may not be diagonalizable. Therefore there is no relation between the diagonalizability, nilpotent matrix and the companion matrix. If the matrix is companion, then it may be diagonalizable, may not be diagonalizable. It may be nilpotent, it may not be nilpotent. Similarly for idempotent matrix, there is no direct relation between the companion matrix and the idempotent matrix. The matrix may be idempotent, may not be idempotent. Suppose if we take these types of matrix for x square, then 0 0 1 0, I think this is idempotent matrix. Just check it once. This is a very easy example. You can check and take and verify. Okay, so there is no such relation between these types of things. Okay, now this is clear. Now I take any another example and find the determinant, trace and so on by a higher order matrix, taking a higher order matrix. Okay, now just a moment. If we take the example, this one, we take 0 0 0 minus 4 1 0 0 0 0 1 0 5 and 0 0 1 0. Fine. So this is a matrix. This is a 4 by 4 matrix. That is the polynomial with associated with the matrix, obviously of degree 4. Okay, fine. So degree 4. Now how can we write the polynomial? So px equal to what? So minus of this one. So minus of minus 4. Then what? Minus of 0 into x. Then minus 5 of 5 into x square. Then 0 into minus 0 into x cube and plus x to the power 4. That is, this is equal to it comes x to the power 4 minus 5x square plus 4. Okay, yeah, I'm writing it correctly. So now how can we write it? This, see, this is, we can write x square minus 4 and x square minus 1. I think that is x minus 1, x plus 1, x minus 2 and x plus 2. So see, what is the minimal polynomial? This is the minimal polynomial as well as characteristic polynomial also. So this is a this question comes in, I think, CSIR exam or any other exam. Okay, so see, this is the minimal polynomial. So what is the minimal polynomial? This is minimal polynomial. This is also the characteristic polynomial. Now what are the eigenvalues of this matrix? The eigenvalues are, so if we take this is equal to 0, we then definitely get the eigenvalues, or the eigenvalues are what? Eigenvalues are -1, 1, -2 and 2. Okay, these are the eigenvalues. Now what are the trace? From eigenvalues we can check trace of A. This is equal to -1 +1 -2 +2 0, and date of A equal to what? Date of A equal to, suppose this is A, date of A equal to 2 to the 4, so this is 4. Okay, or date of A equal to 4. Now from this matrix, without calculating this portion, we can also check. How can we check? See the matrix. What is matrix? See, date of A equal to what I say? Date of is equal to product of the matrix, and product of the matrix means what? Always the last term of this entry, the last term of this polynomial, which is equal to, definitely we can say 4, and say date of A equal to 4. Now how can we how can I say that this 4 is the determinant value? See, this is a 4 by 4 matrix, and since if alpha, beta, gamma, delta are roots of this fourth order polynomial, 4 roots, fourth order polynomial, then we know that how can we write the polynomial if these types of roots we get? X to the power 4 minus alpha plus beta plus gamma plus delta into x cube plus product of roots taking sum of the roots, product of taking 2 at a time, that is summation alpha beta into, I think the sign will be different, maybe differ. Okay, x square, then taking 3 at a time, this into x plus alpha beta gamma delta. This is the procedure if we know the 4 roots of a quadratic polynomial. Okay, so that means what is the trace? Trace means this one. Trace means this one. Okay, if we write plus, I think it is minus, plus, it is minus and plus. This minus plus minus plus is the rules to taking write the root. So that means this is the trace and this is the what? The determinant of the matrix. So this is very easy. See, that means the determinant value is 4, and what is the trace value? Trace of A equal to coefficient of the lower terms, the highest terms is x to the power 4, that is coefficient of x to the power 3. The second highest most terms, the coefficient of the second highest most terms gives you the trace, and here there is no x square present, that means 0 is the trace. Fine. Okay. Now I can also write the Jordan canonical form of this matrix from this matrix. See, these are the 4 different eigenvalues, and if we all know that if the minimal polynomials has distinct linear factor, then there are 4 Jordan block and one eigenvalue is one block. Okay, that is -1, 1, -2, 2, and all are the elements are 0. Since one eigenvalue occurs 1 times in the minimal polynomial and distinct factor, that is this 1 is a complete block, this -1 is a complete block, 2 is a complete block, -2 is a complete block. And we also know that the highest order block in the Jordan canonical form gives you the highest order factor present in the minimal polynomial. I think I am saying right. Okay, so these are the complete position or complete things regarding the companion matrix. I think this is sufficient to solve any questions related to the companion matrix. I will discuss you the eigenvalue and eigenvector. You can also calculate from here. Eigenvalue, then trace, then determinant, then Jordan canonical form, and the short tricks also to find the trace and the determinant. And if the determinant is 0, then you can say that this is one eigenvalue should be 0, and these types of most common things you can also say from here. Okay, so if this video ends here, I ends this video here. If this video is helpful for you, I know that definitely this video will be very helpful for you. Okay, so obviously give a like to this video, and don't forget to make any comment in the comment section below, and obviously share and more with your friends. Okay, thank you, bye, मिलते हैं अगले वीडियो में. हरे कृष्ण.